Hello everyone, welcome to the Y-Axis Pod. I'm your host Tristan Yver, and today I have with me Yannick Schrade. He's the CEO and co-founder of Arcium. They are a private computation network built leveraging the Solana blockchain. They're working with some pretty exciting privacy stuff, and they're doing something that I haven't seen anyone else focus on, and so I'm pretty excited to have Yannick here with me today. Welcome, Yannick.
Thanks for having me, Tristan.
Yeah, and I think for this one, let's just jump right into it. I want to ask you, what is Arcium? What was the reason you guys built it, and what does it do?
Yeah, so with Arcium, we're building the encrypted supercomputer, which might sound super ominous, but what we're enabling at the end of the day is for any computation, be it an on-chain or off-chain computation, to be executed in a fully encrypted, entirely private way. And this kind of computing, where you're able to run any kind of computation over encrypted data in a private way, is what we started to coin and call Privacy 2.0. So for us, Privacy 1.0 really is more of a transactional thing, but Privacy 2.0 enables all different kinds of applications because now there's no limit to privacy. Now you can just run any type of computation in a fully private way. And that ranges from private DeFi applications, where we are able to onboard entirely new players into the DeFi setting, up towards fully encrypted model training, all coordinated on-chain.
So yeah, talk to me a little bit more about that. I know that a lot of the critique we're seeing right now for crypto is that it's some of it's self-fulfilling. It's not looking beyond sort of like the trading or financial speculative elements of crypto. I'd love to hear some of the use cases you could see for a network like this in the outside world, or for example, who would be ideal consumers or customers of this if this gets outside of crypto?
Yes, I think one of the interesting aspects for us really, and that also has been the reason why over time we evolved towards Arcium, is that it's not really this self-serving thing for the crypto space. I think that's part of what you're describing product-wise, where it's just this big circle, this echo chamber, if you will, right, where products exist. So we of course enable all different kinds of new crypto products and more powerful crypto products. And I think it's interesting to see from my perspective the type of teams that started building with Arcium, that started building applications that you previously didn't really consider to be possible on a blockchain, because since everything is public by default, right? I think one of the interesting aspects is that we are leveraging blockchain technology, not in an artificial way, but it actually makes sense from a, I guess, cryptographic game theoretic standpoint. We require a blockchain to offer this kind of privacy in a suitable way. And so what we enable through this setting, through Arcium being an encrypted supercomputer, which at the end of the day means any computation is private, is fully encrypted, but Arcium itself isn't a stateful blockchain where you need to deploy smart contracts or that produces blocks, but instead it's a purely computational network. And so what that entails is also being used in an off-chain setting without whoever uses Arcium caring about the blockchain nature, only caring about the privacy 2.0 that Arcium is offering. And so most likely we'll be starting to announce some of those, I would call them Web 2 institutional partnerships, of people starting to use Arcium in this way, players who've never touched blockchains before in their life, and not caring about that, only caring about this kind of privacy, especially in the context of AI, of being able to train models and infer into models in this fully encrypted private way, where it becomes possible to process way more sensitive data, way more valuable data, which is distributed across all different kinds of people and players without any of them having to share their data. That's one of this, one of the
And
key aspects
is that
of the tech.
so something that came to mind is I could imagine there's medical research happening, and each different medical provider is restricted by their privacy acts and their ability to share or not share their, I'm going to say customers, but they're not really customers, their healthcare patients' information. Would this be such that it comes in, it just is redacted as far as the person's name, and that part of it is impossible to pull out, or the entirety of the data set is encrypted, but there's a way for the other people working with that to infer facts? How does that work?
Excellent question. So it's not just their name being hidden, right? That would just be anonymization, I guess, right? Obfuscation, where you would just, I guess, process the data and then send it somewhere. The data itself is never being sent somewhere. The only thing that is ever being sent somewhere is the encrypted data. So you always encrypt it on your machine, right? The patient has their patient file, health history, that gets encrypted. And there isn't a key for anyone else to decrypt it. It's gonna be encrypted, and at that point, it remains in a secure representation. And the traditional approach now is that in order to be able to process this data, it has to be decrypted, right? How else would you be able to do anything with that data? But what we're saying with Arcium is you don't have to decrypt it. Everybody can just encrypt their data, and then we can take all of that encrypted data collectively and train something on it. And the secret underneath all of that is modern cryptography. And
So
through that,
as long as you can validate that these are encryptions of valid data, then the computation of all of it should give results for each of the people that provided data that is meaningful to them, right? Is that okay?
I mean, so it's I think one of the go-to examples, and we're using different kinds of cryptographic primitives within those computations, but one of the key primitive, the core primitive for us in this stage right now is secure multi-party computation, which a few folks might be familiar from MPC wallets, I guess, but MPC in general allows a set of participants to jointly compute a function over distributed private data without having to reveal that private data. And so we are leveraging this concept onto a higher level, I guess, to be able to run any kind of computation in a fully encrypted way. And one of the go-to examples, I think, is a set of players simply wanting to compute the average of their wealth without sharing their wealth. And so with secure multi-party computation, that's incredibly straightforward to do so on a secure protocol where everybody inputs their own secret value into the computation. Nobody else can see the secret value. But at the end, everybody knows the average. So that's the most simple MPC protocol you can implement, but you can leverage this technology to represent basically any kind of computation and make it more complex and not just operate over integer values, but also real number values, and then for AI tensors. And so you can build those black box computations, if you will, where everything remains encrypted.
That was going to be my next question. I was trying to visualize this. And so essentially each player submits data into a black box, which is able to look at all that data, but is protected cryptographically. And then it gives an output based on all those inputs that were put into it, and depending on what was asked for.
So the black box itself is the distributed network, where all participants, or I guess in practice a subset of the participants, because Arcium is partitioned into computational clusters, but those sets of players, they run the computation. And so I specify, hey, I have this set of 100 players, and I want those 100 players to process my computation. Now, what I do is I encrypt my data, submit it to them, and they can run the computation. They can't see the data, but they can run the computation. And how it works basically is that in our protocol, we operate in the so-called dishonest majority trust assumption. Usually you would see honest majority trust assumptions for these kinds of protocols, similar to Byzantine fault tolerance, where you have to trust that, some threshold of participants, I guess, which usually would be more than half, behaves honestly, behaves according to protocol in order to guarantee privacy or a correct output to be produced. And we felt like that wasn't a good enough trust assumption, really, to give these systems and a distributed open network your data, having to trust that so many participants have to be honest. And so Arcium operates in the dishonest majority trust assumption, which means one single honest participant in the entirety of this network is required to behave honestly, which just means isn't maliciously collaborating with all of the others to undermine the privacy. And that's a incredibly powerful trust assumption because that makes the entire computation setup more scalable and brings trust down to relative zero. And so with this trust assumption, what those nodes are doing basically under the hood is for every epoch within the Arcium network, which is the clock, I guess, with which our network is running, those nodes generate some random keys in a so-called DKG, distributed key generation protocol. And the result of this computation, where they collaboratively generate keys and everybody ends up with their own key that nobody else knows, is that a public key is being produced. And then anyone can take this public key and encrypt their data with this public key. And at that point, it's possible for the network to process the data in the multi-party computation without having to decrypt it, because the private key to this public key doesn't exist. There's only key shares, and you would have to take control over the entire network. You would have to take control over every single key share in order to be able to do anything with this data that isn't according to protocol. And so that's a very nice trust assumption and allows us to operate those computations through this distributed key generation and MPC setup. And so that's the basic flow, where you encrypt something and then you send it to this, I would call it virtual black box. And this virtual black box consists of a lot of nodes that have to run the computation in a specific way and can only run it in this way, and then at the end produce the verifiable output and send it back to whoever. And the output that is being produced, that's also important, can be public. So let's say you're actually training an AI model through, I guess, a smart contract, right, on top of sensitive data. You could specify that the model that is being produced actually should be public and then should land on the ledger or off-chain, whatever, right? But anyone would have access to that model. But what's interesting is that you can also say, I want the model to remain encrypted in the same way as the inputs were encrypted. And so the model that is being produced then through this computation can be fully private without a single user, single party, anyone being able to see the model weights. And then you can say, okay, but now if you want to use the model, you again submit encrypted inputs for the inference. You have to pay some fee through a smart contract. And then you can run the secure multi-party computation where the encrypted model is being taken, your encrypted data is being taken, they're being processed together, and the output at the end is now encrypted again, but only encrypted so that you have access to the output. So that's, I think, very interesting, because teams and companies can build very interesting applications with that now.
So yeah, first to the security assumption, I think that makes a lot of sense, because you're using basically the distributed security guarantees of a blockchain to make it much harder to gain access to this data, right? Versus like if they're a centralized private compute provider, if they get hacked, everything is out in the open. Is that like the right way to think about it, basically, from the security perspective?
Exactly. So we don't want to have single points of failure. So that's why
Yep.
we chose the most distributed protocol, I guess, and want to enforce distribution, which is where that's one aspect where the blockchain connection comes into play. But there's actually also a second component which also ties into security, but that is
Well,
censorship
let me
resistance.
let me stop you real
Yeah.
quick just to make sure I understood. So,
Yeah.
um, and essentially with these models that are being created, would you be able to create a model and then charge a fee for an external party to come and use your model with their data? Is that sort of what you were describing, or is that
That's what you could be
it's like a
doing.
possibility?
Yeah, that's a possibility. That's what you can build. What you can also build is that whoever provided input data, if you have really training to inference, everything private and decentralized, right? With no trusted intermediaries. You could say everybody that provided data to the training automatically gets a fee share from anytime someone runs an inference into the model. Things like that, which are very interesting because for decentralized training and a lot of things in decentralized AI to actually make sense, you need this kind of privacy 2.0. And we're actually very lucky, I guess, at Arcium because we've been developing this cryptography and one one new protocol in that area with, I guess, the most trustless, I guess, attributes of the last few years. But what we did last year is we acquired our largest Web2 competitor, who've been doing private AI using
Mm.
MPC for more than 8 years, and so we've acquired them, brought the team into our team, and their technology, their protocol, which had been used in defense, TradFi, and healthcare for many years, and are now, instead of having it as they had it in this closed up proprietary company where you, I guess, had to go through some SaaS like payment infrastructure into this open network that anyone can use, this encrypted
Hmm.
supercomputer where anyone can just access encrypted computing for whatever applications they want to build. And so, yeah, we've really focused over the last few years on building out the tech that is especially required for fully encrypted on-chain applications. But now, together with this AI technology, merging them together, we can run any computation in this fully encrypted way. So it's not just model training. You could just, if you have access to some incredible data set, right?
Yeah.
You could just define any arbitrary computation with your models in that computation and monetize that in a distributed way. And we have teams building that on top of Arcium right now, where it's possible to, as anyone, monetize their models and workflows for other people to use with their sensitive data. And this core problem of I don't want anyone to see my secrets, which are so valuable, right? Because it's this powerful model. But there's so many companies and people that would benefit from using that and would pay for using it. At the same time, those teams also don't want to send you this data that they want to input into this computation or inference. And so that big problem really gets resolved. And that's only resolvable through privacy 2.0. That's not resolvable through zero knowledge proofs or anything like that, which is sort of privacy 1.0. It's really privacy 2.0, where we need to be able to operate over encrypted shared state, where it's shared state from
Mhm.
different parties and everything encrypted so that nobody sees anything.
A question for you before I go, continuing sort of what you've been talking about, going back to this single honest node example for security. How's the network able to know who the honest player is? Like, let's say if there is only one honest player.
Um, so there's two definitions of being an honest player. The first definition is in the context of privacy. So if we have, let's say, 1,000 nodes, right? And all of them are dishonest. So the entirety is dishonest. There isn't a single honest node. There's 1,000 evil, dishonest nodes. What they can do is they can combine all of their secrets together in order to be able to exfiltrate information which isn't according to protocol. So that's the worst case that we want to prevent. So we need one single honest node out of those 1,000 that doesn't collaborate. And why is it required that there's one single one? Simply because of additive homomorphisms. So what that means is you have a secret, and that secret is being split into 1,000 random numbers. So you have 1,000 random numbers, and if you add all of those 1,000 random numbers together, you receive some secret. And so you want to have at worst only 999 random numbers in the hands of one party.
Right.
And so we always need to ensure there's at least two parties, I guess, right? One big Sybil attacking the network and then one secondary party. And so you can't upfront verify this kind of behavior as being honest, right? Because that's impossible to verify. There's protocols that I guess down the line we might implement where any kind of non-protocol or any kind of decryption.
So it's probabilistic versus deterministic, right?
Exactly.
Because the probability of one, like, of there not being a single honest in the 1,000 is like just so low that it stops being a vector.
Especially, exactly, and so there's that for one. That's one. The other one is, why don't you, Tristan, since you're so afraid, join the network and become honest?
Right, exactly, yeah, exactly.
Right? So,
or if you guys have a foundation, they run a
exactly.
node that will always be honest or whatever.
And so that is one aspect, public reputation system, all of that. And so from a relative standpoint, the trust assumption is zero because I'm honest. I have stake in skin in the game, right? The other aspect for honesty is practical honesty, because one of the big issues for dishonest majority protocols in the past has been their lack of practicality. Because while from a privacy standpoint, the trust assumption has been ideal, one of the big issues has been that one dishonest player could just DDoS the computation, because during the computation they could share some invalid data or go offline. But since the system runs on top of those additive homomorphisms, there's this requirement for participation. And so someone could just censor a computation, and by default those protocols can only abort in such a case. They can't identify who's the misbehaving party, which is very bad. The computation would just end for all participants with an error, because they would detect someone tried to generate fake the computation or do whatever, right? And so that has been very bad. And so with this kind of constraints, it's very difficult to run such a computation in a distributed setting, right? I would say it's impossible. And so what we instead have built is we've greatly improved the security model by being able to actually cryptographically identify this kind of misbehavior. So we can just cryptographically identify this kind of misbehavior and pinpoint the exact participant that caused a failure, and then through existing blockchain networks, right?
Then you have slashing.
Solana, we can just slash them and we can require them to stake. And that makes the protocol super practical. That makes this very efficient, very trustless protocol super practical. And I think that's one really significant aspect to our architecture as well. And so those are two sides of this I guess honesty coin. And in general, I would say 1 out of n is incredibly nice as a trust assumption and scalable if you compare it with Byzantine fault tolerance, right? Where you have this enormous network and still you need maybe 2/3, to be honest.
Um, yeah, thanks for explaining all that. When you mentioned that you guys acquired this Web2 company that was doing their own form of private compute, and you mentioned that they were working in potential with military companies, but also with TradFi. What's an example of each of those two industries that could benefit from this?
Yeah, so I think especially in this military and intelligence setting, it's very interesting what you can do. So I think a very simple aspect is you have multiple organizations that all have information but cannot share the information. But you can, for example, find intersections in that information. So you can make some sort of explorative data analysis across agencies, which can lead to more collaboration in those areas where you can identify, okay, here we have some overlap without having to share that data, right? Otherwise, that wouldn't be impossible to identify. What Infra had been doing as in regards to projects in that area, I can speak publicly about, has, for example, been things like secure flotilla management. Things like, okay, we have those airplanes and we have those boats and whatever, and those are being managed through some secure platform where there's nobody that can see anything, and you can have access control with different people having access to different devices. And I think connecting all of those devices with what you would traditionally call IoT, I guess, deepen, and that natively leads it to some secure multi-party computation setup where you actually can do some interesting things. And so at the end of the day, what the technology introduces is encrypted computing and the removal of single points of failure. And I think that's something that in those industries you're also quite interested in, because single points of failure is something that in most computer architectures you're quite keen, regardless whether or not you're into decentralization or centralization, right? You want to overcome. In TradFi, interestingly, what it had been used in the example of Infra, the company that we have acquired, is compliance. So being able to do compliance checks on financial transactions of individuals and their behavior, I guess, without any trusted third party looking into all of their financial doings, right? So it would be some automated checks without the risk of the data being exposed. Only in the case of, hey, here's some problem, it seems like, then it would be possible to I guess, give the data to whoever, right? But it would be forced through this algorithmic rule set of this is what has to be the case, right? And in their case, that was really through some AI protocol. So I think that's also a very interesting aspect of this technology, because the way I see it really is that everyone will be using it. And so that means it will be used by people who want to add more freedom to their lives. It will be used by companies that want to protect their secrets. It will be used by governments, by military organizations, by TradFi. At the same time, you can also use this technology to make things like what you traditionally would reject, I guess, from this crypto and libertarian idea, right? Of I don't want any compliance or surveillance or whatever. You can make those processes way more privacy preserving as well, even if at any point you need them, because you can define rules on what happens with whatever the input data is, and if and only if condition X is met, then the data can be transferred to some party, and that can be verifiable, and that can be made in a way where the entire process is trustless because it's transparent through some distributed ledger. So I think that's very interesting as well. Because
So a question for you, Yannick, and I feel like I have the answer close to mine, but this compliance example is a really good example because I know it's one of the fields where a lot of this privacy preserving technology would be very, very useful, especially because these institutions just suck at preserving our data and keeping it private and whatnot. But I've heard examples of people touting ZK proofs as a way of compliance data sharing. And I'd love to hear sort of the comparison between that versus this privacy 2.0 perspective of doing a similar function.
yeah, that's actually a very interesting question because, and we've been building with zero knowledge proofs in the past, right? In the past, Arcium had a different name, and we evolved into Arcium, and also from a technological standpoint, we evolved from zero knowledge proofs into this verifiable, secure multi-party computation. Zero knowledge proofs run in the setting where I have some sensitive data and I want to prove some computation over the sensitive data, right? So it doesn't have to be sensitive data, I guess, private data, right? So I have private data and I want to run a computation over it, and through running this computation with that private data, I generate a proof and I give that proof to you, Tristan. You can verify it. You can be convinced of the truth of some statement that I make, the statement being the computation over the private data, without you having to see that statement. So you're convinced of the truth. So I just perform a local black box computation, if you will, right? So I build this computation, and the output, the proof, is basically this black box that I send your way. You can check this black box and be like, okay, if the black box definition is Yannick is an adult male, right? Which could verify based on my ID that is stored in some encrypted database, whatever. And only I, of course, have access to my ID. So I could generate a zero knowledge proof that I'm this adult male, could send it your way, and you could be convinced of that without having to see my ID and the location where I live and my exact birth date, right? Those things. And so that's a zero knowledge proof. Two parties involved, prover and verifier. And that leads itself to scenarios where you can have this interaction, where one party actively holds their privacy and their secrets and generates information about it. And at my disposal, basically, I can share something with you. I can generate a zero knowledge proof and share that with you. In the context of compliance, what that means is that every time you, as the compliance authority, would enforce compliance, I would have to become active and share something with you, which can make sense. But I think what makes more sense instead is also at whoever's disposal, I guess, but being able to actually automatically run a computation without requiring me to share something, because let's be honest, in most cases where you actually want to have compliance against some folks, exactly these kinds of folks won't be sharing anything. And so instead what you want is, and that's something that is mostly relevant, I guess, to the DeFi setting where people are introducing privacy to DeFi, is being able to, similarly to what Infra has been doing, I guess, be able to run computations over encrypted data without requiring me to get active, right? And so that would just do the compliance automatically. And all of that based on publicly available rules that apply to everyone and in a verifiable way. So I think that's one of the big differences, and that has a lot of practical implementations, not requiring whoever is the one party involved to become active and actively maintain their secrets and run computations over that. Which especially I think, and we've seen that in the past, was very very difficult to navigate in the whole tornado cache setting, right? Tornado cache being a prime example of privacy 1.0, where it's transactional privacy using zero knowledge proofs, whereas privacy 2.0 is run some computer program in an encrypted way. But with tornado cache, I think we saw that where, what are you gonna do when you receive funds from a tornado cache address, right? You can't prove some compliance about that. It can only be the sender who can do that, and I think that's a problem in the permissionless setting, and it can be done in a way where the recipient can do that as well, without require or automatically it happens, right? So I think this whole concept of compliance in the decentralized world can be resolved in a very nice way through privacy 2.0, where we can say we can add compliance without having to compromise privacy, because we don't introduce some trusted third party that now maintains all this private data and is able to do the compliance. Instead, we can say compliance is being enforced in an autonomous, encrypted way, and I think that's very nice.
Yeah, with a public rule set that everyone is on the same playing field.
Yeah.
A question for you, Yannick. I mean, this is maybe dumb, but the nodes for the network, when you say compute, are these nodes actually providing the compute capacity for the computations, or are they more so providing like entropy for the cryptography? What does it mean to be a node, I guess, for the Arcium network?
Both. So so within Arcium we have two, I guess three, but mainly two MPC protocols, which are closely related. You can switch between both, but those are at the end of the day backends. So you could think of them as operating systems, I guess. And so those two backends, Cerberus and Manticore, the one that we've developed over the last few years, the one that we've acquired, are fine-tuned for different use cases. One for real number arithmetic, the other one for integer arithmetic, and those backends is what the user can run their computations in. They can access that through our dedicated Rust compiler, or they can use the Python interpreter, where they just write some Python program, but mainly Rust, I guess. And so that's how people access this network. And so the question arises, if I want to, let's say, build some application that just encrypt, where user is able to, let's say, store encrypted data or manage some keys governed through a smart contract. That would be one application. And another developer says, hey, I'm building out encrypted neural network training. So two applications with very different computational complexity. And so from a node operator perspective, what it means is that in order to provide computing power and this role of also not being a dishonest player, or potentially, I guess, being an honest player out of a larger set, right? It's not just about how much power can I provide. It's also this role in this network, right? So for one use case would require less compute. For the other one would require way more compute. And for the AI one, might actually require them to have a graphics card, some powerful graphics card, right? And so it makes sense for us to try to differentiate those use cases as well and say, okay, it should make sense for a node operator to be able to specialize, to be able to come to the table, come to the network with whatever hardware they have, and then unlock their hardware based on a staking and stake delegation system, and then be able to provide computing power for more computational clusters, for more users, for the network to have a higher dependence on them being online and acting correctly, I guess. And so I think that's one aspect, being able to specialize on a hardware level for what kind of protocols you want to run into. And at the same time, I think there, as I outlined, there's different kinds of applications to be built. And so right now it's us developing this network, right? So there's this vision that I have of how it should look like. But similarly to if you look at Solana with SIMD 228, the way I see it really is that down the line you will really have more economy around the specialization as well, because there's a lot of value involved for durability of some encrypted data, encrypted secrets to ensure that even in 10 years from now I can still access it, right? And so I think there will be way more I think the system will greatly evolve over time once it becomes public, because then there will be potential for the entire fee model to evolve. So in general, I would say computing power is both entropy, the computing resources you provide as entropy and actual raw computing units per units of time. How much can you process in a given time? Yeah.
And does the entire network work on anything that comes to it together, or is it based off the nodes that you choose to do your computation? Like, how do you do that selection?
Yeah, so it's not the entire network. That's when I said earlier, the Arcium network is partitioned into those dishonest majority clusters. And so you could be part of every single computation cluster within Arcium, I guess. But I, as a computation customer, I can just pick some random nodes. If I deploy a smart contract, if I, let's say, were to build some dark pool on chain using Arcium, and now I'm thinking, okay, what cluster within Arcium should process those computations? I can use existing clusters, and how it looks like basically is I create what is called an MXE, MPC execution environment. That's something that I deploy with my smart contract. And then I say to this existing cluster, hey, I invite you guys to process the computations for my MXE, which basically is this contract that not a smart contract, not a legal contract, but a logical contract, I guess, that me and those nodes sign. Because if the nodes, for example, at some point then say, oh, no, I'm not going to process it, that's a censorship action, right? And so that they will get punished for that. And so I can invite those nodes to process such a computation. At the same time, nodes are able to in schedule leave those clusters or fork clusters in order to leave specific MXEs.
In all this, Yannick, where are you guys right now? So what state of this network is alive? What's coming next for you guys? Where do you stand?
So we are currently in private testnet, and we are moving into public testnet. I think we're going to announce the exact date actually next week. So we are moving into public testnet next month, which is something that I've never said in the past, but but yeah, we are really
Leaked here.
in this final stage of giving everyone access. So right now, we have both crypto teams building all different kinds of applications. So it's not just DeFi and decentralized AI, but there's also teams, building things like an encrypted DocuSign on the blockchain, right? Things like that. Applications
Mhm.
where previously you wouldn't even have dared to dream of those applications, because how would you bring some sensitive contracts on top of the blockchain, right? And make signing verifiable and add information redaction and all of these kinds of things. So very new kinds of applications. And that on the crypto side, but at the same time, we already have folks in the let's call it real world, working with Arcium as well to protect some very sensitive data. And I'm very excited to be able to announce that very soon. And so what's keeping us from being in public testnet right now, or since a few months, I guess it's just the enormous amount of engineering that flows into building new cryptographic protocols. And it's not just that, it's not just this core cryptography of our network that I guess just and our team exists of a lot of PhDs and the smartest people in the entire cryptography space, but still it takes time. But it's not just this core cryptography, but also, and I think that's one of the most important aspects to all of this, I think, is abstracting all of it away from
Yeah, that's what I was
developers.
gonna ask.
And that's the difficult part.
Because
It's
you want people to show up and it's like setting up an
yeah,
AWS bucket or something, right? Like,
exactly. It's I mean it's relatively straightforward to say, hey, I've developed this protocol. All you need to do is write your own mathematical formulas and encryption stuff. But I've created this core protocol, right? So it's quite easy to also give developers a domain-specific language, where with that domain-specific language they require some PhD in mathematics in order to be able to add private compute to their application. So all of that is very undesirable, and the experience that we need to provide is developer experience, good developer experience, the best
mm,
developer experience, and so that's what we're focused on, to just abstract all of those things away. And yeah, I think one of the key developments that we've undertaken in that aspect is our Rust compiler, Arcis, which just allows you to write normal Rust code and make it
mm,
private. And for the developer, it's just specifying what should be processed in private, what should be encrypted, who should have access to something. And yeah, I think that's really where what drives adoption, both in crypto but also outside of crypto, because nobody wants to have to specialize in something in order to use it.
yeah,
And there's already enough trade-offs involved, I guess, right? In everything. Even though we're super efficient with Arcium and orders of magnitude faster than fully homomorphic encryption, for example, of course there's some technological trade-offs you always have to look at. And so what you have control over is removing the trade-off from developer experience, right? From this tooling.
mm,
So I think that's what you need to do, and the team is really focused on that as well. So I think that's something that actually takes a lot of time, because that's like fine tuning a user interface, right?
yeah. No, it's completely fundamental. And do you think that, once this is up and running, if the network works great and all of the cryptography and code and whatnot is great, does the next step become a sales mission or a sales problem to go and get folks to want to use this, or do you think the technology will be so good that they'll just innately use it, because why wouldn't they?
Um, so at least in regards to us onboarding our first extremely conservative, traditional, and fingers crossed, I hope to be able to announce that soon, or be allowed to, non-crypto customer that was zero sales and BD work. That was us being proactively approached by them. So I found that very interesting, and especially really in the scale of things, it's incredibly interesting. I think what we've seen in crypto is that within crypto there's this enormous demand for this kind of technology. So I think a very good example was last year at Breakpoint. The amount of developers and teams wanting to build with us. And a few weeks ago, when we were sponsoring the Mountain DAO and we had the Arcium week there, it was incredible to see so many developers starting to use it at that stage, right? During Breakpoint, it wasn't the case, but a lot of people interested. And so I think in general, within crypto, there's less of a BD requirement actually. I think that will really be the expansion to traditional industries, where I really see, in general, see this requirement of there needs to be sales, there needs to be people that have a foothold in those specific industries, right? Because it might be difficult to in some of those industries come there as a 24-year-old crypto startup founder and tell them to use some privacy preserving technology. But I think in general, what we've seen is incredibly gives us a very incredibly optimistic perspective around all of that so far.
That's awesome. Would you be able to describe how the network interacts with the Solana blockchain? Because I know that a lot of what you guys are doing is tied to them. And I don't mean just from a technological perspective. I just mean that, a lot of the rapport and energy that is focused on you guys, as you said, from the developer community, from the retail community, is from the Solana side of things. So I'm curious how those mesh together.
So I think one of the first alignments really is IBRL, right? Both the entire Solana ecosystem, everybody in the Solana ecosystem, and including Arcium wanting to increase bandwidth, reduce latency, always be faster, always make things, be able to process more, process faster. So that's also, I think, one of the reasons why we as a team 3 years ago got into Solana, right, and are so closely aligned with this ecosystem. And from a technological standpoint, what blockchains mean for Arcium really is that Arcium is, in its current form, right, the stateless, purely computational network. And on top of Solana, there sit programs, smart contracts, that sort of function as consensus and coordination for Arcium. And so you can have computation to be scheduled to be executed from within a smart contract on top of Solana, and Arcium picks that up. And so there's some CPI invocation, some cross-program invocation coming from one program on Solana to Arcium. Arcium processes it and then sends a callback. So that allows for asynchronous, encrypted execution within existing programs, right? And so the technological connection is having different programs on top of Solana that serve different functions for the network, including staking and slashing, right? So all of those aspects that also improve, yeah, I guess security of the network. Then yeah, I guess cultural alignment is very high as well. And I mean, what for you is the reason why you've been in the Solana ecosystem? What would be your reason? I think that's also cultural alignment, right? And having this shared vision of how you go about things. And so I think that's very, very strong in the Arcium
Yeah, I
team.
mean, for me, it was just signing that first transaction with Solid, putting a limit order into Serum Dex in May 2020 or June 2020, and seeing how fast and cheap it was, and saying, wow, this was the best blockchain experience I've had so far. Even though all the tooling and the wallets and the UIs were janky as could be, the fact that that transaction confirmed so quickly was a very exciting moment for me. And then I think that my view just got validated as more and more L2s started coming out. And as I had worked for a long time in the exchange industry, I knew how important liquidity was. And so
Hmm.
that I knew that any modality through which fragmentation of liquidity becomes a norm will be very hard to compete against a more monolithic competitor that has all the
Yeah,
liquidity in
yeah,
one place, has all the action in one place. So that was my sort of turning point
yeah.
back then. Um, so yeah, like you know, I wasn't gonna mention it, but you brought up slashing and staking already like twice. So I'm gonna ask you about the Arcium token. I'm guessing that is in the works. How does it mesh with this network? Is that what's getting slashed when a staker gets or when a node gets slashed?
So yeah, that's currently in the works. There's also gonna be some public information about this. I am quite sure when this goes live, most likely. Um, so how all of this works is that we enforce execution through this staking and slashing mechanism, which is based on this cryptographic identification system for misbehavior in the network. And the network really functions around you being able to, if you want to run a node on, I haven't tested it, but running it on a Raspberry Pi
Hmm.
might not make sense, but you could do that, right? And however, wouldn't be able to now process 1 million transactions per second with that, computations per second with that.
Hmm.
Instead, you would have to unlock this potential of being able to process a lot of things in parallel. And also, as a side note, what's interesting is as if you are part of two independent clusters, right, that run computations, it's relatively easy to understand, okay, I can run two computations in parallel for those two clusters. But you can
Hmm.
also run computations for the same cluster entirely in parallel. So that allows me to say, yeah, 1 million computations per second. That's not
Hmm.
some stupid L2 claim that claims to be able to process a billion
It's actually
transactions,
multi-threaded.
right?
Like it's real. It's real
Exactly. It
multi-threaded.
actually you can yeah, you can scale it. It's scaling vertically and horizontally at the same time, I guess, right? Um, and so you being able to process whatever with your hardware and your network link, um, that's something that isn't, yeah, 100% verifiable, right? And so you create this claim of being able to process so much, and this claim also entails you being willing to do so, right? And so according to that, you stake, and based on that, you can then get slashed. So this increases potentially the dependence of the network on you. Yeah, and so I think we have some more complex design components circling around.
Hmm.
Um,
Right, because
Demand
you want
and
to avoid
supply.
like everyone just staking to the most powerful node that's able to service the most computation, right? Like that's a threat vector.
Um, would be a threat vector, yeah. But the stake delegation system basically runs with a sublinear curve. So there's a point in time where it's more capital efficient to instead delegate to another party that has less stake delegated to them. So we have a native way of incentivizing this kind of distributed staking. Yeah, and also I guess another aspect is the player you're staking to can specify what the reward is for the delegators, right? Or their own fee share, I guess. So that really incentivizes someone running a node and, for example, specializing on providing the required hardware, while third parties provide the capital to unlock that hardware, which is very interesting. And also this adds more accountability to those parties as well. And with the sublinear curve, we introduced this native incentive for distribution. And as I said, there's basically a market around what's the price for confidential computing, and that currently runs on a system where there's stake weighted voting by every node operator, also based on their actual role in providing computations, I guess, not just stake, but that's the way you can think of it, around the base price for computations, and then on top of that base price, based on local fee markets for unions of computation clusters, there's priority fees. And so there's a mechanism, I guess, associated with those priority fees as well. But
so if you're in a rush, you want to do your private computation faster than the others, you can pay a priority fee to get you ahead of the queue.
Exactly. Yeah, exactly. And so
the same way with transactions on Solana, essentially.
Yeah, exactly. That's how it functions. And so all of those aspects allow for different token economic designs. And so we've spec'd something out in accordance to all of that. Yeah.
One last question on all of this before I move into some more personal questions about you and the team is, what are calls to action now that you have testnet coming soon? Is there anything you would be good for you to have people do? Are there people that, what would be the call that you would make as testnet goes live?
So I think what we'll be providing with public testnet as well is public demonstrations, because sometimes it can actually be difficult to realize the power of the technology, right? We can talk for hours about encrypted computing, private computing, but actually being able to touch the system and feel it processing something in an encrypted way, I think is highly valuable. So in general, what I would recommend, because there's I think a lot of interesting announcements. I don't know when this is gonna go live, but in general, there is a lot of interesting things that we will be sharing. So my recommendation to anyone that wants to stay up to date would just be to follow us on X and join the public testnet, both as a developer, but also as any kind of user interested in the power of privacy 2.0. Because as I said, you don't have to build your own application. You can also just play around with these kinds of demo applications. So I think that would be my direct call to action. When do you think this will go live?
Likely in like 5-6 days.
Okay, sounds good. Yeah, so then at that point there will be some big announcement, most likely live on our Twitter. So you should
Just
now
follow.
go to our Twitter.
Yeah. One thing that came to mind for me just now as you were describing that is, I think potentially something valuable for you guys as a company would be to subsidize case studies on allowing people to do interesting private compute for research purposes or things like that. I think that could be a really cool method of messaging for the world, is just to have different examples of case studies of people you've worked with, and you subsidize it, but it shows the impact this can have in the real world as well.
Yes. Yeah. Yeah. And actually, it can, I mean, especially when you say research, right? And that's something in the actually research in the, let's say, clinical sense. It can actually already have great impact. And those are industries that, regardless, would would in general be more difficult to get into, right? And so I think
Hmm.
that would be that's a smart approach of yeah, getting a foot into the door and actually building up a track record, right? I think that's something important because um, it's always, I mean, at the end of the day, I can refer whoever to the underlying math, right? But not everybody will take a look at the math. Also,
Very few
not
people
everybody
will ever
will
take a look. Yannick,
yeah.
there are very few people who will ever take
Yeah,
a
yeah.
look at the
Not
math.
not everyone, yeah. No,
It's
no.
gonna be like
Nobody.
if you get a big contract and they're gonna, and
Yeah.
if they have a cryptographer or something, they're gonna make him look, right?
Yeah. But and at the same time, so you shouldn't take me at what I'm saying at
Yeah,
face
yeah.
value, right? Because the whole point of what we're building is you don't have to trust Yannick, instead math. So
Yeah, yeah. No, I'm being
um,
flippant, but I
yeah, no,
totally
no,
hear your point.
but
And
yeah, no, but actually, I think you having track record, especially in research, right? Um, I think that makes a lot of sense. And our team has that, but I think collaboration with more different players is a very interesting concept.
so
Yeah.
that's a good segue into, so for the listeners, Yannick's team has been known pretty much from the very start as very strong cryptographers and mathematicians, and just very smart people in general. I'm curious, Yannick, how did you guys end up in crypto? Why was that the industry that you chose to build in when you founded this?
Um, so currently at Arcium we are around 20 people. I think four PhDs in mathematics, cryptography, and I'm actually from our founding team of four founders. I'm actually the most new um, in crypto in our team actually. So
Hmm.
I've joined really in crypto, yeah, 4 years ago, something like that. So that's when I joined crypto specifically for us to found Arcium, and the others have been in crypto for longer, and also significantly longer. And so for me, it was only a technological thing. So when when I was maybe 11, 12 years of age, I taught myself programming, and then after high school, for some godforsaken reason, decided to study law. And
Hmm.
everybody was like, "Hey, Yannick, you should study physics, mathematics, or computer science." But Yannick wanted to study law, so that's what he did. But during studying law, I developed an app for the iPad and iPhone, which then quite quite rapidly actually became one of the most sold productivity apps in the entire world on the App Store. And at some point, I think the most sold. And so, and that was after a few months after I just developed that app during lecture free time, in a couple of weeks, because I wanted to have something like this, and so I just decided, okay, let me just put it on the App Store. And so at that point, then I was like, okay, either I do this kind of stuff or I do law. And at that point, I was doing my large criminal law course, and so then I decided to instead be studying mathematics and computer science,
Hmm.
which is then where I met two of my co-founders, and yeah, I think we had this shared interest in the underlying technology, which at that point started with zero knowledge proofs. So very interested in this new cryptographic concept, and that's what got me into crypto, because that was really the research front of this kind of technology, which is very interesting. I think that yeah, a lot of this cryptography really has been accelerated through all of the yeah, investment, I guess mostly within the crypto space. So I think that's
Hmm.
incredibly valuable. But we had started with that, and that's what really brought me into crypto. So I didn't start, as I guess many did, by trading anything, but really thinking about the potential applications of this kind of technology and being greatly excited by that. Yeah, and since then we've evolved a lot. A lot of new team members have joined. A lot of new team members have joined that for many years have done cryptography, but never had any touching points with blockchain. So
Hmm.
very interesting to be onboarding all of them. But it's super interesting because we did this acquisition, right? Of players that have been in this traditional industry, but all of them are so greatly aligned with this vision of saying, hey, we're going to make it permissionless. We're going to build an encrypted supercomputer that anyone can use. And that in itself, I've noticed, is a big motivation to the people in our team, because they want to bring this vision to the world. So it's not just the CEO that has that vision and is fighting to bring that to the world, but the vision itself, this kind of vision that we have, also really motivates the entire team. And I think that has been amazing to see.
That's awesome. Yeah, I think once the company becomes mission driven, everything becomes possible. It's such a different story than trying to convince folks to come up the hill, right? When everyone's just pushing as hard as they can. That's really good to hear. I'd be curious, Yannick, so you guys have been working on this for quite some time, right? It's been a buildup of foundational pieces that has allowed for the Arcium network to almost be live now. For you, is the overwhelming mission or torch just bringing privacy to the world, bringing privacy to the internet, or what is that core sort of essence that keeps you pushing?
Yeah, that's a great question. So I've been thinking about that myself, because this I have this I mean, from I guess philosophical standpoint, I'm convinced of the value of privacy to an individual, right? So at the same time, I don't see what I'm doing with Arcium um, as me leading the charge for bringing privacy to the individual. Instead, I feel like um, privacy should be part of any system, both to the benefit of the individual, which I think is incredibly high, but also for collectives of individuals, right? Which is companies, countries. So any type of collection of individuals as well. And I think that's an important aspect that you don't see that often, where it's only focused on we're gonna bring privacy, and privacy means you as the individual are gonna be protected. But I think any any form of any set of humans in that regard, and I think what I find so important really is AI in this context. I think talking about the transparent nature of blockchains, right? That's how we got started with Arcium, in order to provide privacy on the blockchain, where everything is public by default. That has evolved into, okay, there's so many single points of failure in this entire internet infrastructure. There's so much data that actually exists that nobody is using. There's so much data that nobody is using because it's not possible to use that data because it's so sensitive. So you should never give all of that data to some central party that promises to process in a secure way. So there's this enormous amount of highly sensitive data, and there's so much untapped data that can help humanity because we can use that data to build some predictive models that I guess most tangibly in healthcare will allow us to make bigger progress. At the same time, we shouldn't, from a political standpoint, right, from this philosophical idea of privacy, we shouldn't give that data to the government or some company to process it. At the same time, from a security standpoint, right, we shouldn't be doing that. And so that's where Arcium comes into play. It enables these kinds of new, more powerful applications, which become very tangible in the sector of AI, where we can now use this data that previously existed only in isolated data silos. And so I think what originally got me into it was, okay, I want to protect the privacy of the individual. But as the technology that we've built evolved, it also evolved towards, I will always fundamentally will want to protect the privacy of the individual. But I will not achieve that by I guess being the preacher on the marketplace, saying you need to have privacy. Instead, that will be achieved by building technology that enables more powerful applications, and that's Privacy 2.0 that we're building with Arcium. You can have more powerful applications. You can use all of this sensitive data in a secure, fully private way without anyone ever having to share any information, and that makes those systems more private, more protected, and I think I would say that's what motivates me. Yeah.
And my final question for you, Yannick, in this startup journey that you've been building this company out, what has been the most important lesson that you've learned for creating success within a startup or a company?
So I think, and I might not have a super concise one-liner lesson right here for this, but more of a concept in general that I think I've noticed quite often, and I think you yourself have for sure seen it as well. And that is, I think, also always remaining, I guess optimistic, and I think it's easy to, especially in crypto and in startups in general, I think it's easy to see other players, right? Other players succeeding and then looking at the market. And I think your benchmark shouldn't be other people. I think that's my lesson. I think the benchmark shouldn't be other teams. I think you need to build whatever your vision and mission is, and that will lead to success. And so I think focusing too much, not just on competition, but on short-term market trends as well, is something that you shouldn't be doing. I think what you should be doing is you should have an image of the world, how that world will look like, with the kind of product or technology that you're building in place, and then working towards that vision. And I'm at least convinced that that's something that leads to success, and we've been doing that over the last few years, and it really has been a tremendous experience, and yeah, to have assembled that team and to have so many developers and companies now starting to use us. So I think that's really key, sticking to your vision, but also what I think is also an important aspect in that regard, and that's something that we, so it's not just one lesson, it's an entire
All good. Give us the
hour of
compendium.
lessons. I think is not being afraid to, and I mean, that might sound contradictory to sticking to whatever your mission is, but I think you need to evolve. You need to have the potential to evolve and to pivot, right?
Hmm.
That's what we did. We didn't pivot in a 180-degree way where we said, "Hey, we're doing privacy," and then at the end of the day, next day, "Hey, we're trying to undermine privacy," right? We said we were privacy 1.0, now we're privacy 2.0. So it's a logical evolution, I guess, but still, especially when you have investors and you've already built a brand, deciding to rebrand, to pivot, to basically, yeah, have spent a lot of time and resources on developing something. I think that's something that requires a lot of courage, but is required more often. I think most successful teams and players I've seen, they haven't been afraid to pivot, right? I mean, even pivot in regards to what your messaging is, right? To
Hmm.
just pivot in that regard and don't just try to stick to the same playbook. So I think the bigger underlying vision, that's what remains unchanged in general, I guess. But more of the mission on top of it. That's what can evolve and change and needs to be adapted, of course. And so I think, yeah, that's at least what I've been trying to do with Arcium, and which has led us to where we're at right now. And I guess whoever listens to that can judge if that makes
No,
sense.
I agree.
Yeah.
I think most of the great companies have had quite significant pivots and a lot of times maintain the underlying vision and mission, just it has a different expression as it hits the market or
Yeah.
the world.
Yeah.
Um, and yeah, thank you so much for coming on, Yannick. This was a really nice conversation, and also thank you for building privacy. I think it's something that is so difficult and so taboo in so many ways that a lot of people don't even give it a try. And so I think it's very, very important for all of us, for humanity in general, to be able to have a technological world that also includes privacy. So it's very exciting, and I hope you guys succeed massively.
Yeah. Thanks for having me, Tristan. It was my pleasure.